All right, to finish off section 3.2, let's do one application of least common multiples. Just to point out one special case, if you find both your numbers are prime, you can multiply the numbers together to get the LCM, or least common multiple. For example, if you were asked to find the least common multiple of 3 and 5, since both of those are prime, you would use 3 times 5. And if you think about it, if you were doing this using the tree method, for example, for 3, your answer is just going to be 3 is the prime factorization. For 5, the prime factorization is just 5. So when you go down by column, you're going to end up with 3 times 5. Okay. Equivalent fractions, remember we touched on this in a different chapter, really all mean the same amount of stuff. So if you have this chocolate bar, you divide it into 3 pieces. One of those pieces would be 1/3 of this chocolate bar. If you divided it into 6 pieces, 2 of those pieces would be 2/6 of this chocolate bar, and it would still represent the same amount of stuff, right? It's still the same amount. And same with 12. If you divided the chocolate bar into 12, you can see that 4 of those pieces would also be the same amount. Okay, if we want to compare fractions, it's easier if the denominators are the same. And so there's a way we can make those denominators the same so that we can compare the fractions much easier. So if you're asked to compare two fractions or figure out which one's bigger, first you want to find the least common multiple of the two denominators. There's a special word for that. The least common multiple of any two denominators is the least common denominator, or LCD, least common denominator. So when people say least common denominator, they really just mean least common multiple of the denominators. Denominator. Okay, so we're going to find the least common multiple of those denominators. That will allow us to figure out what the equivalent fractions are, and then it makes it way easier to compare those fractions. So for example, take a look at this first question here. They ask, which is larger, 5/9 or 4/7? Well, I find that hard to picture. If I had a pizza cut up into 9 and I had 5 of them, do I have more or less pizza if I would have cut it into 7 equal slices and taken 4? That's hard to picture. Let's make those the same denominator. So step 1, we're going to find the LCM, or least common multiple, of the two denominators. So which method are we going to do here? Let's do the division method. So our denominators are 9 and 7. So we're looking for a prime factor. This is a great example because we haven't done yet one with where we only have 2 numbers, have we? So we've got 9 and 7. There are no shared prime factors there. So if there's only 2 numbers, I can take the prime factor that divides into at least 1. So here that gives me a 3. 9 divided by 3 gives me 3. And then I've got my 7 over here. Well, 3 and 7 are prime, so I can draw myself my L. I know I'm done. And my LCM, or I'll call it LCD because it's actually the lowest common multiple of the denominators, is 3 times 3 times 7, which would be 9 times 7, or 63. So I know my denominator should be 63. So now what I'm going to do is find the equivalent fractions for each of my fractions with their new denominator of 63. So I've got 5/9. Okay, so I want to find what number will that be over 63. Okay, well, let's look at what we had to do to get from 9 to 63. So to go from 9 to 63, we had to multiply by 7. That means we also have to multiply our numerator by 7. And so our answer here is going to be 5 times 7 gives me 35 over 63. Okay, then I've got 4/7. So we're going to do that. We want that with our new denominator of 63. So we're trying to figure out what over 63 would be the equivalent fraction. It's kind of like we're taking our chocolate bar and dividing it up into smaller pieces. So what did we have to do to get from 7 to 63? What did we have to multiply by? Here we had to multiply by 9. So that means on the top, we're also going to have to be multiplying by 9, which will give us 36 over 63. Okay, so step 3 is to compare. So we're going to compare. So our first fraction here is 35 over 63. That was what 5/9 was. Our second fraction is 36 over 63. Which one of those two is larger? Well, here we've got 63 equal pieces of something. And in one case, we have 35 of those pieces. And in the other case, we have 36 of those pieces. So the 35 pieces is less than, which means if we have 5/9 and 4/7, the 5/9 is the one that's smaller. All right, let's do another one. So we want to know which is larger, 5/9 or 6 over 11. Okay, so step 1, we want to find our least common denominator. Here, let's do the tree method. So we've got 9, which is 3 times 3. We've got 11, which is actually prime. So when we go to do our prime factorization table, 9 is going to be 3 times 3. 11 is going to be an 11 on the end. So our least common multiple here is actually going to end up being the product of those two numbers. So 3 times 3 times 11 gives us 9 times 11, which is 99. So step 2, we're going to take each of our fractions that we're trying to compare. So 5 over 9 and 6 over 11. We're going to put those into equivalent fractions that are over our new denominator of 99. So for the first one, we're going to ask ourselves, what did we have to multiply to get from 9 to 99? Okay, another way to say that is, what is 99 divided by 9? And it's 11. So 9 times 11 gave us 99. That means we have to multiply our 5 by 11 as well, which is going to give us 55. Okay, second one there. So to get from 11 to 99, we had to multiply by 9. And if you're not sure, on your calculator, do 99 divided by 11 and you'll get 9. So on the top then, we have to go from 6 to something. We've got to multiply again by 9. So 6 times 9 gives us 54. Okay, so that means we're really are comparing. If we've got 55 over 99 and 54 over 99, the 54 over 99 is the smaller one, so we're going to have a greater than symbol here. 55 is greater than 54. And so that means that in our original fraction, it's going to be the same relationship. So 5/9 is greater than 6 over 11. That last question here for this section asks you to rank these 3 fractions from smallest to large. So using the same skills we just learned, so first step, you're going to find the LCD, least common denominator. Then you're going to figure out your equivalent fractions that are all listed over that common denominator. And then last step is compare. So try that one on your own, pause this video, and then see if you can get the answer there. Okay, let's do this. So we want the LCD of these 3 numbers. So I'm going to use the division method, which used to be my least favorite method, but it's growing on me. So we've got 8, 16, and 32. All of those are divisible by 2. That'll give me 4, 8, 16. All of those also divisible by 2 to get 2, 4, and 8. Divisible by 2 to get 1, 2, and 4. And those are divisible by 2. I can't divide my 1, so it just comes along for the ride. 1 and 2. So now I can draw myself an L. Okay, and my least common denominator is going to be 2 times 2 times 2 times 2 times 1, but they won't affect the answer, times another 2. And the answer here will be 32. And just a little tip for you too, if you see that all of your denominators are, if one denominator is a multiple of the other two, so here the 32 is a multiple of 16, it's also a multiple of 8. That's also a tip that your least common denominator is going to be that larger number because it's a multiple of all three. Okay, so we've got our least common denominator is 32. So step 2, we're going to figure out our equivalent fractions. So we've got 5 over 8, and we want that as something over 32. And so to get from 8 to 32, we had to multiply by 4, which means we have to multiply by 4 on top to get 20 over 32. Okay, and then our second one there, we've got 9 over 16. We want something over 32. So this time we had to multiply by 2. And that's going to give us 18. And the third number there is already over 32. So it's 13 over 32. So step 3, maybe I'll do it over here. Step 3 is going to be to compare. And so maybe this is easiest. Let's write out our original numbers. We had 5 over 8, 9 over 16, 13 over 32. And so we said 5 over 8 is really the same thing as 20 over 32. 9 over 16 is 18 over 32. And 13 over 32 on the end. Okay, so if we were to rank these from smallest to largest, we would have 1, 2, 3, which means our original numbers are 1, 2, and 3. So if we're writing these from smallest to largest, our answer then is going to be 13 30-seconds, then 9 over 16, then 5 over 8. And if you're really good with a tape measure, an imperial tape measure, you might have known that already, just from where those measurements would be on a tape measure. So that's it for least common multiples or least common denominators and starting to use them to compare fractions that are unlike.